Okay, so the tool we're going to use for making structural predictions or for understanding small molecules is Lewis dot structures. That's the tool we're going to use. And so in order to appreciate this, let's first of all remember that the outer electrons, that is those that are available for bonding, are called valence electrons, right? So the valence electrons are the outer electrons. And the number of valence electrons is indicated by the group number. Do you remember what the group number is? Look over here at the periodic table. The group number, this is group 1 over here with hydrogen, lithium, sodium, potassium, group 1. Group 2 is beryllium. Group 3 is boron, aluminum, gallium, right? Carbon, silicon, germanium is group 4. Group 5 is here. Now there's a couple naming conventions for the periodic table, right? So this is called group 1 or group 1A or group 11A, right? I think that's a misprint. That's definitely a misprint, okay? But this is group 2A or Roman numeral 2A or 2A, all right? I'm just going to call it group 1. And this I'm going to call group 2. I'm going to call this group 3. You can see that sort of fits with these other two naming conventions, the lower two, all right? And group 4 and 5 and so on. That's not really important what naming convention we use, of course, or else they wouldn't be 3. But anyways, just to point that out. Group 1 has 1 valence electron. Group 2 has 2 valence electrons. Group 3 has 3 valence electrons. Group 4 and so on. Does that make sense? All right, so again, the number of valence electrons is indicated by the group number. All right? Now, finally, bonds are formed by the sharing of valence electrons. We call those valence electrons, when they're shared, we call them covalent electrons, right? That's what a covalent bond is. Okay? So let's look at a question that we might get from a section like this. Draw the Lewis structure of a boron atom. Okay, so for a boron atom, let me come here in blue. I'm going to say the Lewis structure. We're going to indicate the core of the boron atom. That is not the valence electrons, but all the inner electrons. And the nucleus, we're going to indicate just with the chemical symbol B. All right? So then we're going to indicate the valence electrons by coming over here. Boron's in group 3. Can you see it right there? Okay. And so I'm going to say 1, 2, 3. That is the Lewis structure of a boron atom. By the way, it's just as accurate to say 1, 2, 3. And it's just as accurate to say 1, 2, 3, right? So typically, I'm going to start, I guess, on the west side of this boron atom and sort of go around, but I don't know why I went to the top. Doesn't matter, right? This is the Lewis structure of a boron atom. I'm not indicating anything in particular by where I put those electrons. Oftentimes, I will pair them. Okay, so let's now do the Lewis structure of a nitrogen atom. So again, first of all, I'm going to draw the core I'm going to indicate the core with the chemical symbol. That's both the nucleus and all the inner electrons. Now we draw the valence electrons with Lewis structures. Let's go over and see where nitrogen is. And boom, there it is in group 5, right there. See nitrogen? Group 5. Since it's in group 5, it has 5 valence electrons. So I'm going to go 1, 2, 3, 4, 5. Okay? And that is the Lewis structure of a nitrogen atom. Okay? Again, we might have drawn it 1, 2, 3, 4, 5. This is equally correct. Okay? And generally, especially for the smaller atoms, we're going to draw them only on the left and right and top and bottom. Right? So we're going to pair them. All right, so those are the Lewis structures of atoms. Now, let's consider the Lewis structure of a, I guess I was putting that in the front. Let's consider the Lewis structure of a molecule. This molecule is formaldehyde. Okay, and so let's do what we did before. Remember now from previous lecture that carbon has a tendency to have 4 bonds. Oxygen has a tendency to have 2 bonds, and hydrogen has a tendency to have 1 bond, right? So let's first of all draw these guys. They're going to be central because they have more bonds, right? And now let's draw the hydrogens. Well, I could draw a hydrogen here and a hydrogen here, which I'm going to do because carbon's wants to have 4 bonds, right? And oxygen wants to have 2 bonds, right? Okay. All right, so let's draw the Lewis structure of CH₂O, which is formaldehyde. First thing we're going to do is we're going to draw all the atoms, and we're going to assume that they're symmetric. Let me get that back in blue. Let's assume symmetry here. Okay. Right, and now I'm going to draw the valence electrons. Hydrogen is in group 1. I'm going to draw an electron there. I'm going to draw an electron here. I'm assuming it's going to share something over here with carbon, right? And oxygen, I'm going to say 1, 2, 3, 4, 5, 6. Okay? And carbon is in group 4, so it's 1, 2, 3, 4. Okay? Now we're going to assume these guys are bonded because that's what a molecule has, right? Covalent bonds. So I'm going to say, I'm going to redraw these 2 electrons in red. I'm going to draw these 2, and I'm going to draw them as a covalent bond. I'm going to draw these 2 as a covalent bond. I'm going to draw these 2 as a covalent bond. Now remember, from a previous conversation, the carbon has a tendency to have 4 bonds, and oxygen has a tendency to have 2 bonds, right? So look at this. If I take this electron and that electron, and I'm going to erase it and redraw it here, right? Then, sure enough, I've got carbon with my 4 bonds and oxygen with my 2 bonds. It looks like oxygen's got 2 lone pairs of electrons also. Okay, so the last thing I'm going to do in order to appreciate if that's a good structure or not is I'm going to subject it to the octet rule, which I said nothing about so far, but the octet rule is something we learned in a previous class. The octet rule, I'm going to go with gray, okay? So for the octet rule, I'm going to circle each atom and count every electron that's inside that circle, right? These electrons are covalent, right? They belong both to the carbon and to the hydrogen. So it looks like there's 2 electrons here. Since hydrogen's in the first period, it only has a capacity for 2 electrons, so that's fine. Looks like that's in the same shape, right? 2 electrons, and that's fine. Here are all the electrons that are in the valence shell of carbon. 2, 4, 6, 8. That's fine. And here are the valence electrons that are in the, the valence electrons for the oxygen. Again, remember, these 4 electrons are covalent, right? 2, 4, 6, and 8. Okay? And so it looks like that satisfies the octet rule. In fact, that is the Lewis structure of formaldehyde. Sometimes what I'm going to do when I'm done is I'm going to redraw everything, make it a little bit prettier, right? Especially if I didn't give much care when I was doing my notes to its shape. It might be confusing in the end, it got so much there. And sure enough, this is the Lewis dot structure of formaldehyde. Okay, hope that's helpful.